Okay, we're going to be looking at an answer key for just a few problems to kind of walk through the 4 rules that I gave you on assigning oxidation numbers. We're going to start with the first rule, and that first rule is at elements are 0. So if you notice on this page that I have in front of us, I'm only going to do part of the page just so you get the general idea. Elements are 0, so where do I assign a 0? I'm going to put 1 there, I'm going to put 1 there, and I'm going to put 1 there. Those are elements. How do I know they're elements? They don't have a charge dangling off on the side, and there's only one capital letter. The next rule that I have is exceptions. I always look for exceptions. The first exception that we had is hydrogen is -1 when it follows a metal. So I'm going to take a look now, and I see a hydrogen here, and I ask myself immediately before that, is that a metal? And the answer is, yes, it is. So in that case, that is going to be -1. Okay, there is one more on this, what I see right here in front of me, and that is this scenario right here, -1. Oh. Come on, let's go. Okay, -1 for this guy right there. All right, there is one more somewhere out on this page, but we're just going to worry about what we see, because as soon as I start playing around with this page, it takes me longer to do these, and I know that some of you don't have the time. Anyhow, the next one that we have is the oxygen exception. Oxygen in a 2-2 relationship binary compound where both subscripts are 2s. The oxygen that's the only time oxygen in a compound would be -1, and that is right here. There's another scenario where oxygen would be positive, and that is when it's bonded with fluorine, and I did not give that in the notes, but I just wanted to mention it now, that OF2, that compound, that is the only time where oxygen would be positive, and the reason is because fluorine is so electronegative, it gets the electron and becomes negative. All right, so now that we got that all covered, I'm going to now change the color of the pen so that we realize that we're just going to fill in the normal numbers for oxygen. Anywhere I see an oxygen, it's going to be -2, -2. There's an oxygen right there, that's -2. Watch how fast this is going. -2 for that one, -2 for that one, -2 for that one, -2 for that one, -2, -2, -2, -2, -2. Mr. Zakari, how can you do this so fast? You're making it look easy. That's because it is. If you just follow the rules in that order. When you don't follow the rules in that order, it makes it more difficult for you, and I can totally understand why students would have a problem with this. But if you just follow the rules in that order, look for elements, scour the page, anywhere you see an element, give it a 0. Look for the exceptions, and then anywhere else you see O and H, just assign their normal numbers, and the normal number for H that we said was +1. So I'm going to change the pen once again so we can see the normal number for H right here. +1, +1. Scanning the page. Any other H's on here? Nope. Oh, yeah, right there. +1. And right there, +1. And that one's +1. All right. Now, oh my God, we filled in most of the page already. So what else do we have to do? Well, periodic table will help us with anything with binary compounds. All you got to do is grab the top right corner. I'm going to change the pen again just so that we can fill in the normal periodic table numbers here. I got +1 and -1. That's +2 and -1. I'm going to get to that iron in a second. That one's +1. There's only one oxidation number. That one's +1. That one's +1, -1. That one's +2. Let's see, that one's +1. And that one's +1. Now the remainder that are on this page, guys, all you have to do is use a few of the rules that we had left over. Rule number 3 is if you have something that you're uncertain about, like for instance this iron right here I'm uncertain about. Why? Because when I look at my periodic table and I look at the box, iron starts the compound, it has a +2, it has a +3, and I got to figure out which one of these it is. This is where you do the compounds rule and you set Fe2O3 equal to 0 on the bottom. -2 for oxygen, a box over this guy's head. Multiply on the way down. This number times that number is -6. +6, I'm going to divide by the 2 that are contributing to that +6, giving me iron +3. That's the number for iron over iron's head. You can use the compounds rule for this next one. Compounds rule right here would be with H2SO4, we have the H and we have the O, and it looks like we're good to go. H2SO4, it's got to add up to 0 since it's a compound. I know that that's -2. I know that that's +1. I'm multiplying my numbers on the way down, and I got to figure out what's the missing number. Missing number is +6. We only have 1 sulfur in that compound. That gives me +6. Same holds true with this one. That one's going to be +5 when you go ahead and figure that out. But let's prove it right now with this polyatomic ion sitting over here in the same polyatomic ion that you notice right here, PO4, is this polyatomic ion right here, PO4. All right, so now that we got our eyes situated on that, we're going to take a look at how to do PO4. This is the polyatomic ion rule. There is a -3 hanging off on the side of this guy's head over here. All right, so we go -2. 2 times 4 is 8. Missing number +5. And didn't we get the same number as before? Yes, we did. And that's all you have to do, guys. It's the same idea throughout the rest of the page. Just want to take some time out to point this out. If you need any Google Meets, just let me know and I'll be happy to help you.